Yeah, good evening everyone. Good evening. I think I came a little early. Right? Yeah, let me ready all the things. So today's topic is, I think yesterday, wherever we stopped, right, from there I will start. So let me write the date now. Today is, I think, 15, 5, 15, 7, 25. This is the today's date. Yeah, I think we can start. This is the place yesterday we stopped. Right, this is the place where we stopped yesterday. Yeah, I think we can start now. We can start. Yeah, the people, right, because it is a recording also available, so people can watch whenever they want. Yeah, we can start comfortably. We can start. So I'm starting now. 15/7/25. So today's date. Topic is simplification of context-free grammar, which is also called as reduced grammar. Right now, I think before going to start, I want to ask all the people. Is audio video okay? Let me know first of all, audio video okay? Yeah, good evening Alok, good evening everyone. Please let me know, is audio video okay? Check once. Is it fine? Yeah, can we go ahead? Yeah, I think we can go ahead. Right, let's start. Yeah, this is the starting of today's class. Right? Simplification of context-free grammar. So which internally contain, this topic is internally contain three things. One is null production elimination. Null productions elimination. That is the first point. Null production eliminations. Second one is, first one is null production elimination. Next one is unit production elimination. Third one is useless symbol elimination. First one is null productions elimination. Next one is unit production elimination. Next one is useless symbol elimination. These are the three things. Useless symbol elimination. These are the three. Remember, this is the order also. If you don't follow this order, if you do whatever way you want, most probably at the end of all these three steps, you may not get the simplified grammar. Try to understand. So if you want to simplify grammar, you have to apply these three in this order only. Null productions elimination, unit production elimination, useless symbol elimination. If you do like this, right, in this order, you will get the simplified grammar. If you don't follow this order, there may be a chance that you've done the three steps, but it is still not simplified. So in this order only you have to do. Please be careful. It is a number one, it is a number two, it is a number three. Now, before going to the actual procedure, one by one, let me explain. What is the meaning of null production elimination? What is the meaning of unit production elimination? I will explain one by one. Right? Let's take one example. Just I will try. One example. S goes to AB. For everything, I will give one example. After all, right, for everything, one example is over. Combinedly, we will try afterwards. First, let me give one example for each. S goes to AB, A goes to A R epsilon, B goes to B R epsilon. S goes to AB, A goes to AR epsilon, B goes to BR epsilon. In this, you have to eliminate null production. Remember, right? From this, I have to remove null productions. I have to remove null productions from this. How to do? How I am going to do? Let's see. Null productions elimination. How I am going to do? You can see one time. Null productions elimination, right? What is the meaning of null production elimination? Remember everyone. Variable deriving directly epsilon or variable deriving indirectly means like this, right? And the listen, on the arrow symbol, if I write star operator, means indirectly. So on the arrow symbol, there is no star there. Directly, single variable deriving, single CFG means single variable left side. When you say CFG, left hand side, single variable deriving nothing, or single variable indirectly deriving nothing. So, right, these things which we have to avoid. That is the meaning of null production elimination. Directly indirect people who are generating epsilon, we have to eliminate. You may ask that, sir, why you want to eliminate? You may ask me, right? Whenever parsing is going on, if null productions are there, and it will create some problem to the parser. Is a top-down parser or a bottom-up parser? Whenever parsing is going on, if the grammar contain null production, it may create some trouble. So that is the reason we have to eliminate the null production elimination. It is a better. So what is the meaning of null production elimination? Directly variable generating epsilon or indirectly variable generating epsilon, we have to eliminate. If both there, we have to eliminate both. If one there, we have to eliminate one. So remember, direct null productions, indirect null productions, we have to eliminate. That is the meaning of null production elimination. What is the null production? Variable generating epsilon. Directly, indirectly. Those null productions we have to eliminate. Some people are asking, sir, can you give answer of ongoing problem? I'm giving now. Can you give answer of ongoing problem? I'm giving. Everyone see the answer. S goes to AB. Write as it is. Listen carefully, everyone. S goes to AB. A goes to A or epsilon. Please write as it is first. Don't do anything. Please write as it is. B goes to B or epsilon. A goes to A or epsilon. B goes first. Write as it is all. See how I am eliminating. See how much easily I am eliminating. Can you see this one? S goes to AB. A goes to A or epsilon. B goes to B or epsilon. How I am eliminating null, right? Directly, indirectly, you can see now. First, as it is, copy. Okay, I copied. First, as it is, copy. You no need to do anything. First, copy as it is. Okay, done. After doing, listen, everyone. After doing, first of all, identify where is the null production. I think this is where is the null production. First of all, identify. Okay, I identified. So who are generating epsilon? I think capital A also, capital B also. Capital A also generating epsilon, capital B also generating epsilon. We have to eliminate that null production. Then what you do is, before eliminating, wherever capital A there, replace by epsilon. On the right hand side of the production, wherever you see capital A, keep the epsilon. Wherever you see capital B, keep the epsilon. Right hand side of the production. Try to understand. So I think S goes to AB. I think here A there. Replace A by epsilon, you will get B. Next one. Replace B by epsilon, you will get A. Right? Wherever you see capital A on the left hand, on the right hand side of the production, replace by epsilon. Okay. Wherever you see capital B on the right hand side of the production, replace by epsilon. So if I replace this capital A, by epsilon, B I will get. If I replace this capital B by epsilon, then A I will get. Right? But one more thing. You may say that, sir, if I replace both A and B by epsilon, then what the answer? So you will get epsilon. Right? So wherever you see in the A, you replace it by epsilon. Wherever you see in the B, you replace it by epsilon. That's fine. I think everything you done. Now what you do is, now wherever you see epsilon on the right hand side, delete it. Wherever you see epsilon on the right hand side, simply delete it. Because we don't want, you may say that, then why are you replaced? Because of I cannot keep them directly, so I replace it first. Whatever happened. Now all epsilon things I delete. But remember, before going to delete epsilons, that effect you have to keep first. Before going to delete epsilon, that effect you keep. What is that effect? If at all in the AB, A epsilon, B will come. Yes. In the AB, if B epsilon, A will come. In the AB, if A and B both are epsilon, then epsilon will come. So before going to eliminate epsilon, please keep their effect first. Yes, I kept. Then now delete the epsilon. Okay, I deleted. So after deletion, if you observe clearly, S goes to AB. See the grammar now. S goes to AB, or A, or B. Next one, A goes to A, B goes to B. A goes to A, B goes to B. So please be careful. So this is the meaning of elimination of null production. This is the meaning of elimination of null production. This is the actual meaning. If anyone having small doubt also, in the original grammar, small ab possible or not, verify. In the original, before elimination of null production, in the original grammar, AB possible. I think possible. S goes to AB, A by A, B by B, AB possible. Right? After elimination also, S goes to AB, A by A, B by B. I think AB possible. So before AB possible, afterwards also AB possible. Next one more thing. Sir, before AB possible, afterwards also AB possible. Okay. Sir, before elimination, only single A possible? Yes, of course. S goes to AB, B replaced by epsilon, A replaced by A. Single A possible. Here also single A possible. Check. S goes to A, right? S goes to capital A replaced by small a. I think possible. Here also small b possible. How it is? S goes to AB, capital A replaced by epsilon, capital B by B. I think here also B possible. What I mean to say is, before whatever possible, afterwards also possible. Before elimination, whatever possible, after elimination also everything possible. But there may be a chance that one minor difference there. What is that one? In the original grammar, epsilon possible. How? S goes to AB, A by epsilon, B by epsilon. So in the original grammar, epsilon possible. After conversion or after elimination, after eliminating the null production, right? In the original grammar, epsilon possible, but here epsilon not possible. Maximum epsilon difference may be possible. Maximum epsilon difference. Let us assume that given grammar is G1. Assume. After conversion, you got G2. Assume. Before conversion, G1 is the original grammar. After conversion, G2. Now, if you observe language of G1, right, language of G2, if you observe both of them, either both will be equal or epsilon is the difference. Either both will be the equal or epsilon is the difference. Maximum difference can be epsilon. Right? You may say that epsilon, who is having, who don't have. G1 having epsilon, G1 may have epsilon, G2 cannot have. G1 may have epsilon, G2 cannot have. There may be a chance that both G1 and G2, both don't have epsilon. That is okay. Both don't have epsilon, that is okay. But there may be a chance that G1 having epsilon, G2 may not have epsilon. Because after elimination of null production, you don't get epsilon. So I will write now. For every epsilon free CFG, you will get the equivalent grammar after elimination of null production. Let me write now. We can rewrite we can rewrite equivalent CFG for the given we can rewrite equivalent CFG without null productions. Without null productions. If the original CFG not contain epsilon, we can rewrite equivalent CFG without null productions if the original CFG not contain epsilon. It's a very, very important. It's a very, very nice point. Means we can write equivalent one. You want to say this. When you can write the equivalent one before elimination means in the original grammar there is no epsilon. In the original grammar, epsilon it is not generating. In the original grammar, epsilon is not generating. After elimination of the null production, whatever grammar you will get, there also there is no epsilon. If before no epsilon, afterwards also no epsilon. But remember, if before epsilon, after elimination, epsilon will not come. Then both are not equal. We can rewrite equivalent CFG without null productions if the original CFG not contain epsilon. It's a very, very important statement. Next one. I will reiterate the same statement one more way. I will rewrite the same statement one more way. Let me see. Let me write this. After eliminating null productions, from the given CFG, we may not get equivalent. We may not get equivalent CFG. Means there may be some difference. After eliminating null productions from the given CFG, we may not get equivalent CFG. Means there may be chance of epsilon difference. There may be a chance of epsilon difference. Please remember, it is a point number one, it is a point number two. If you have little doubt also there, you can ask me. Before elimination, there is no null. I'm not saying there is no null production, I'm saying that null. I'm talking about string null. I'm repeating once again. Before elimination, in the original grammar, there is no null string. There is no null string. After elimination also, there is no null string. For those kind of people, you can get the equivalent grammar before, after. Suppose in the original grammar, there is a null string. After elimination, you don't get null string. So there may be a chance that both are not equal. After eliminating null productions from the given CFG, right, null string. Sorry, I'm repeating once again. After eliminating null productions from the given CFG, we may not get equivalent CFG. Simple here, very simple, no need to confuse. Maybe I am confusing you. It is a very simple. Before conversion in the given grammar, epsilon is there. After conversion in the given grammar, there is no epsilon. So you don't get equivalent one. But remember, before conversion in the given grammar, if no epsilon, after conversion also no epsilon, then both are equal. Right? So before epsilon not there, afterwards also no epsilon, definitely equal. I'm saying one thing, maximum difference is only epsilon. Before conversion, after conversion, maximum difference is epsilon. See this one, original one having epsilon, after conversion epsilon not there. This is the maximum difference. So to get the more clarity, I will give one more example. To get the more clarity, I will give one more example, then only you will get it. See this one, example. Example, can you see this one? S goes to, this will give more clarity. S goes to AB, A goes to A or epsilon. This problem will give more clarity. Whatever I am saying till now, you may not get now, but this problem will give clarity. S goes to AB, A goes to A or epsilon, B goes to simply B. Or I can write the C also. S goes to AB, A goes to A or epsilon, B goes to B or C, right? See this one. I am eliminating null production. Remember, I am eliminating null production. What you do? First write as it is. Don't confuse. First write everything as it is. Everything as it is you write. First write everything as it is. Okay. Then what is the next step? Now underline, right? Underline or round epsilon things first. First write as it is, epsilon things you round first. Now what you do is, wherever you see epsilon, wherever you see A, because A goes to epsilon, wherever you see A on the right hand side of the grammar, wherever you see capital A on the right hand side of the grammar, replace by epsilon. Capital A there, replace by epsilon. So B there. Right hand side of the grammar, wherever you see capital A, replace by epsilon. I think only one place I replaced by epsilon, remaining is B. I think if you see the, wherever you see on the right hand side capital B, then replace by epsilon. No, capital B, epsilon not there. So I replaced, after replacing, cancel it. A goes to epsilon there. So what you do, go right hand side, wherever capital A replaced by epsilon. Yes, I written. Right? Remaining thing is, I think B, I written. After writing every way, then cancel the A goes to null production. Now, if you want, you can observe. See, right? If you want, you can observe here. Before conversion, after conversion, you can observe. Everyone observe. Before conversion, only single B possible or not? Let's check. S goes to AB, A replaced by epsilon, B replaced by small b. Yes, possible. Now here also see, S goes to B, B goes to B. Here also B possible. Before conversion, after conversion, both the places B possible. Let's go to only C possible. S goes to AB, A replaced by epsilon, B goes to C possible. Now same thing here also. S goes to B, B goes to C. So I think C also possible. Now some people are asking, what about single A, sir? Before conversion, single A possible or not? Verify. S goes to AB, A replaced by A, B you have to replace by small b or small c. I think here A not possible. If you want, you can check here also A not possible. Before conversion, after conversion, I want to say one thing. Both are same. Whatever, right, before conversion is giving, after conversion also same thing will come. But maximum difference is epsilon. Sometimes no difference at all. If difference is there, epsilon is the difference. So let me write here. Very interesting. Let me write here. Here in before conversion, if you observe, is epsilon possible? Check. Epsilon production there, but epsilon string there or not? We'll check. Before conversion, epsilon production there, but epsilon string there. So no way. S goes to AB, A giving epsilon, but B not giving. So here epsilon here not there. Here also epsilon not there. See the interesting. What I mean to say is before conversion, epsilon string not there. After conversion, anyhow epsilon string will not be there. So definitely they both are equal. If you want, you can check. Maximum difference before conversion, after conversion is maximum epsilon. Suppose left hand side no epsilon string, right also not there. Then exactly you will get both are equal. What is the null production elimination? On the right hand side of the production, I don't want to see epsilon. We have to eliminate them. If you eliminate, what will happen? Because of you are eliminating on the right hand side all epsilons, definitely after conversion, you may not see anywhere right? After conversion, you may not see anywhere epsilon. So after conversion, there is no chance of null string. But before conversion, null string may be possible, right? Then after conversion, null string definitely not possible. So sometimes they both may not be equal, but right, may not be equal, but difference is maximum epsilon. But if you want, you can see this example. The example which I given here, no difference at all. Both are same. So let me write now. It is a G1. Language of G1, assume that L of G1. Assume that it is a G2. Language of G2, assume that L of G2. L of G2. So these two are equal. These two are equal. Whatever left side person is generating, right also will generate same, because maximum epsilon difference. See, epsilon not possible left also. Anyhow, epsilon not possible right. You know, that is the only difference. That difference also not there. So then they both are equal. Remember, in this problem, both the languages are same. But in this problem, both the languages are not same. Before conversion, if you observe, epsilon possible. But after conversion, epsilon is not possible. They both are not same. Here, these two not same. It is a G1, it is a G2, right? L of G1 is this one, L of G2 is this one. Both need not be same. Both need not be same. Epsilon difference may be there. I written the notes also. I written the note also, please check. We can rewrite equivalent CFG without null productions if the original CFG not contain epsilon, right? For this one, below example. Next one, after eliminating null production from the given CFG, we may not get equivalent one. We may not get, yes. We may not. Because sometimes we may get also. I cannot say always you don't get, sometimes you may get. I think I given some idea, right? Null production elimination, I given some idea. We'll see some more problems in the further story. Some more problems we'll see in further story. Can you see next story? Observe everyone. Can you see next story? Can you see next story? Yes goes to. Everyone observe. Yes goes to. Make sure everyone try to get. Yes goes to AB. Yes goes to AB, RC. C goes to RD. C goes to RD. D goes to small d. S goes to AB or capital C. Capital C goes to capital D. Capital D goes to D. Right? That is okay. That is okay. This is the given grammar. Remember, single variable generating single variable. That is called unit production. Variable generating variable. That is called as unit production. That is called as unit production. In the given CFG, single variable generating single variable, that is called unit production. We have to eliminate unit productions. Unit production elimination. Let me write now. Unit production elimination. Unit production elimination. First of all, what is unit production? Single variable generating single variable, that is called unit production. Unit production elimination. How to do? Very simple. I'm writing now. How to do? Very simple. I'm writing. Careful everyone. See the answer. See the answer, everyone. S goes to AB. Is it unit production? No. Single variable generating single variable, that is called unit production. Single variable generating single variable, that is called unit production. Now, I think now observe. Now observe everyone. Now observe everyone. Everyone observe. Everyone observe. RC. C goes to, see this one, D. D goes to, listen, D goes to small d. D goes to small d. Understand here. D goes to small d. S goes to A, B, or C. C goes to D. C goes to D. Remember, this is a unit production. This is also unit production. We have to eliminate. How to eliminate? I'm trying this. We have to eliminate. How to eliminate? I'm trying this. S goes to A, B. Okay. Now see the answer. D goes to D. It is not a unit production. Some people are thinking that left side one, right side one, unit production. No. Single variable generating single variable, that is called unit production. Remember, this is not a D goes to capital D goes to small d. It is not a unit production. Okay, now I think C goes to D. It is a unit production. Remember. So D replaced by, because of the unit production, we have to eliminate D replaced by D right hand side. So D. C goes to D. Instead of writing single variable generating single variable, so in the place of D, write the D possibility. D possibility small d I written. And one more thing, S goes to A, B or C. Remember, it is also unit production. Instead of writing C, write the C possibility, which is the D. Write the C possibility, which is the D. Now let me write. The final one. S goes to A, B or D. C goes to D. D goes to D. This is called unit production elimination. Single variable generating single variable, that is called unit production elimination. Single variable generating single variable, that is called unit production elimination. S goes to A, B, A goes to D, S goes to A, B or D, C goes to D, D goes to D. S goes to A, B or D, C goes to D, D goes to D. Right? Perfect. Perfect now. Perfect now. Check. This is the meaning of unit production elimination. What is unit production elimination? Single variable generating single variable, that is called unit production. We have to eliminate those kind of things. You may say that, sir, what is the need? Right? You only say what is the use of unit production. What is the use? One variable calling another variable, another variable calling another variable, another variable calling another variable. What is the use? It is something like there is a main program. Inside main program, simply one line, A function calling. Inside A function, only one line, B function calling. Inside B function, only one line, C function calling. Inside C function, only one line, D function calling. Inside D function, there is a print hi. Then what is the use of that kind of programming? Main calling A calling B, B calling C. Unnecessary calling. At the end of the day, in the D function, there is a print hi. At the end, it will print hi only. Unnecessarily, why are you going these many levels? Single variable generating single variable. That means one function calling another function without any work. Main calling A, no work before also, afterwards also. Is main function is calling A function, but before calling A, no work there. After calling A also, no work. One function calling another function, in between no work, afterwards also no work. These are called useless things. So that is in the grammar terminology, that is called as unit production elimination. Right? I think you got some idea. I'm not saying that you got everything clearly. I'm just saying that. I'm not saying that you got everything. I'm just saying that everyone be careful. Right? I'm not saying that. I'm not saying that you got everything. You got something. In the further story, you will get the remaining things also. Let's start the next. Example. Right? One more thing. Can you see this one? S goes to AB. Be careful everyone. S goes to AB. A goes to BC. C goes to small a. B goes to B and B. D and B. Next one, capital D goes to EF. E goes to small a. Small e, let us assume that F goes to small f. Guarantee will get. S goes to AB, A goes to BC or A, C goes to A, B goes to BB or DB, D goes to EF, E goes to E, F goes to F. S goes to AB, A goes to BC or A, C goes to A, B goes to BB or DB, D goes to EF, E goes to E, F goes to F, like that. Okay, fine. That is okay. Now see what is the story. Remember, useless symbol elimination. Useless symbol elimination is our goal. Useless symbol elimination. Useless symbols elimination. What exactly it is? It contains internally two steps. It contains internally two steps. First step. Careful everyone. First step. Remember everyone. First step. Not reachable, delete. First step is not reachable, delete. Not reachable variable, delete. That is the first step. Not reachable variables, delete. So some people are asking, sir, who are those? Can you see the answer? Not reachable variable, delete. Can you see the answer? S goes to AB. S goes to AB. Remember, S goes to AB. A required, B required. S goes to AB from the start symbol, right? A required, B required. Go to the A, go to the B. In the A, if you observe, BC already B required. Now C also required. Now, right, BC, right? A goes to BC means B required, C required. Okay, it is a small A. That's okay. Now let's go to the B. If you see the B, right? B goes to B and B. B goes to D and B. No problem. There is no new variable K. No problem. Let's go to the C. C goes to A. There is no new variable. So S required AB, A required B and C. Right? B required B only. C don't require any variable. If you observe clearly from start symbol, no one want D. I think these are useless. These people are useless. From the start symbol, D not reachable. If D not reachable, E and F no use. If D reachable, then E reachable, F reachable. From S, nowhere D reachable. Not reachable variable, delete. Okay, delete. Not reachable variable, delete. So I deleted. Now see the second step. Reachable variable, right? So variables are reachable. But if any variable not generating, remember everyone, if any production not generating string, or if any variable not generating string, we can delete it. Let me write now. Delete, careful everyone, delete those productions which don't generate any string. Which don't generate any string. Delete those productions which don't generate any string. So let me write now. If you observe clearly, observe everyone. S goes to AB. Let us assume, otherwise it is going to be very big story. Please careful. Assume that grammar contain S goes to AB or E also there. Assume S goes to AB or E also. Why I am saying, you will get to know. Right? Assume that in the given grammar, S goes to AB there, E also there. Assume that. Now see this. S goes to AB or E. A goes to BC or A. B goes to BB or DB. Right? C goes to A. Now observe everyone. All are reachable, okay. See this one. B goes to B and B. D goes to, right? B goes to D and B. B goes to B and B. B goes to D and B. Right? If you observe clearly, so it is a recursion. B calling B, recursion. Every recursion should have termination condition. There is no termination. Every recursion should have termination condition. There is no termination. means there is no, right, it's a recursion there, but no termination. So it never terminate, means it don't generate any string. B goes to B and B required. B goes to D and B, so B required. So B calling B, it is a recursion. Every recursive program should need termination condition. There is no termination condition. Means capital B never generate any string. If capital B not generating any string, if anyone based on the capital B, so they will also fail. If anyone based on capital B, they will also fail. Interesting thing is, from S, capital B reachable, but capital B not generating any string. Any person based on capital B, they will be useless. So let's say this one. S goes to E. S goes to E. Right? Remember, S goes to E because of right. S goes to AB. AB required B, so there is no use. Delete it. Next one. A goes to BC. I think it is based on B. Delete it. So A. Right? A. Next one. Careful everyone. Next one is going to be, if you observe clearly, next one, if you observe clearly, yeah, C goes to small a. C goes to small a. But an interesting answer. If you observe clearly, from start symbol, there are some people came who are not reachable. From start symbol, there are few people came who are not reachable. So remember everyone, when you are doing useless symbol elimination next time, first step you do this. What is that one? Right? So eliminate those productions which cannot generate any string. This is the first step. You have to do this as first step. In the useless symbol elimination, do this first step. Do this is second step. Do this one second step, so that if you observe clearly, finally there are some things are there which are not reachable. S goes to E, then what is the use of A? What is the use of C? If you do that, this is first to this is second, you may not get the guarantee. Finally, right? Finally, you may not get the guarantee. It is a right simplified one. First to do this, delete those productions which don't generate any string. That is the first step. Second one, not reachable variable, delete, so that everything is perfect. So I will do the same thing. No need to confuse. Just I want to say that point, that there is an item. So now what I will do is, right, let me do this. If you do whatever order you want, there is no guarantee you will get the simplified one. Don't do randomly. If you do whatever order you want, it may not work. So I will write once again. It will take 1 minute only. So I changed the numbers also. Please careful. I changed the number also. Please careful. This is the number 2. This is the number 1. Right? Let's do number 1 first. Everyone, don't confuse. Let's do number 1 first. What is the answer? What is the number 1? Delete productions which don't generate any string. Delete production which don't generate any string. I am writing now. S goes to, see the answer? S goes to A, B, or E. Reachable or not reachable doesn't matter, right? S goes to A, B, or E. A goes to B, C, or A. C goes to A. Next one, B goes to B and B, D and B. Next one, lastly, D goes to EF, E goes to E, F goes to, careful everyone, F goes to F. Now, what is the first step? Eliminate those production which cannot eliminate those production which cannot generate anything. If you observe clearly, B calling B recursion, no termination. So B don't generate anything. If B not generating anything, based on B you can generate. You can cancel it. Based on B you can cancel. B is gone. Who depending upon B, they also gone. Now first step is over. Whatever answer you got, let's write here. S goes to A, B not there, E. Next one, A goes to, right? A goes to A. Next one, C goes to A. Next one, D goes to EF. D goes to EF. E goes to E. F goes to F. F goes to F. Now observe second step. Now observe second step. Those variables which cannot reach from start symbol. Those variables which cannot start from start symbol, which cannot reach from start symbol, delete them. I think from the S if you observe, what is the answer? A not reachable, C not reachable, D not reachable. You can delete all. So finally, S goes to E. S goes to E. Right? Delete the productions which cannot generate any string. That is the first step. Second step, not reachable variable delete. Not reachable variable delete. This is the useless symbol elimination. Right? In the useless symbol elimination, first thing is going to be those productions which cannot generate anything. Delete them. Next step is generating something but not reachable from start symbol. Those also delete. Finally, S goes to E. Remember, if you follow whatever order you want. Simplified grammar you don't get. In the useless symbol elimination, there are two steps. Right? Right? Productions which don't generate anything, delete them. Next one, not reachable people also delete. Right? So then you will get the simplified grammar. I think I said individually. Please careful. I said individually. Right? So simplification of CFG, right? Which is also called reduced grammar. Null production, first you have to do this. Next unit, next useless. I said for everything 1. I will take one example. I will explain all the three steps. Remember, now I am writing here. Here I am writing. Two steps are there. Here 2 steps. First step, second step. One is eliminate those productions not generating any string, not generating any string. Eliminate productions not generating any string. Next one, eliminate those variables not reachable. So this is the first step. It is the second step. In the third one, it is the 3-1. It is the 3-2. If you follow this order, then only you will get the simplified grammar. Otherwise, you don't get simplified grammar. I hope people got it. Yeah, others is saying that will you take discussion on undecidability and reducibility? Yes. Next one, good evening. Sir, single variable generating single terminal will not be considered unit production. No. Akshay, variable to variable. Single variable. Sir, D producing D is useless? No. So, because D goes to D, it is a string, na? It is generating one string. In the last problem, if you observe, D goes to D. If at all D goes to D, it is generating some string. See, if anything generating something, right, then it is not useless. It is generating something but not reachable. If you want, you can verify. E goes to E, generating something. F goes to F, generating something but not reachable. Delete those productions which don't generate any string. right? If any production not generating anything, just delete first. Next one, they are generating but not reachable from starting state, not reachable from start symbol. Those also you can delete, right? So remember, in this order only you have to do. In this order only you have to do. Be careful, be careful. This order only follow. If you follow some other order, simplified CFG, no guarantee. If you follow some other order, simplified CFG, no guarantee. Let me know anyone having any objection. Let me know anyone having any objection. Tomorrow I will take one example and I will give the right clarity to you. Now itself, I think whatever you got, that is perfect. Whatever you got, it's perfect. Whatever you got, it's perfect. Let me know anyone having any doubt. Tomorrow, as soon as I will start, I will explain, right? One example for all. Then we will go to next story. Then we will go to next story. Tomorrow I will take one good example, right? I will explain to you. And one more, new batch for the GATE 2026 starting. New batch for the GATE 2026 is starting. It is the last batch. You can join regular course also. You can join the crash course also. You can join the RIC course also. You can join the foundation course also. You can join the test series also. Whatever you want, you can join. Right? There is an offer is going on. Buy one, get three. Right? Buy one, get three. There is an offer is going on. Please utilize. Buy one, get three. There is an offer is going on. If you buy regular course, you will get the RIC course test series. Right? If you buy regular CSE course, RIC test series free. If you buy regular DA course, RIC test series free. If you buy regular CSE and DA, you will get the RIC and test series free. Right? Next one, foundation course, 2 years course also you can join. Buy one, get two. RIC, if you buy, test series also free. Right? These are our placement people. These are our placement people. Our students who are placed in the big MNCs. Big MNCs they placed. Right? You can join the DSA course. You can join the programming course. You can join the full stack web development, full stack app development also you can join. Right? Oracle database course also you can join. Right? And one more thing is these are our GATE toppers. These are our GATE toppers who got the 4th rank. Our student got 4th rank. Previously we got the 1st rank, 3rd rank, 4th rank. This year we got the 4th rank and followed by so many good ranks we got. You can see all of them. Right? We'll see tomorrow with some more details. There is an offer going on. You can utilize. You can use the code. EPT 595 ARG. You can use this code to get the discount. EPT 595 ARG. Right? You can use this code to get the discount. Yeah. Thank you so much. See you in the next class. Right? Perfect. Thanks everyone.